Welcome everybody to this training course from ARCHER2, been taught by myself, Andy Turner, and my associate Jeremy Cohen, who's from Imperial College London. I'm from EPCC at the University of Edinburgh. I've got 2 days here. First day I'm going to be leading, and we'll be spending the day looking at Docker and the Docker container technology. And tomorrow Jeremy's going to be leading, and it's going to be more focused on Singularity and Singularity containers. So before we start, I had a couple of things I wanted to say or clear up. So the first one is just around how the session's going to work and what we expect of attendees and ourselves. So the first one is we all, as part of this training, have agreed to sign up to the ARCHER2 Code of Conduct, both us as the trainers and yourself as attendees. And essentially, this is just about being kind and respectful to everybody on the course to foster the best learning environment for everybody. So, using welcoming, inclusive language, being respectful of different viewpoints and experiences. If we're talking about, if we're critiquing things, but we won't be doing much of that on this course, accepting constructive criticism and showing courtesy and respect towards others, and essentially treating people as you'd expect to be treated yourself. If you think there's a problem with the code of conduct, then please feel free to raise with myself or Jeremy via private message in the chat, or also there's a form available on the code of conduct webpage which you could complete, and we will investigate or anything that you raise in this way. I'll put the link in the chat because some people have joined since I last put it up there. Sorry, excuse me. So the way we're going to teach this course is going to follow the Carpentries methodology. If you've been on Carpentries courses, you may be familiar with that. If you haven't been on that before, so rather than standard sorts of lectures and then practical sessions, what we do is we all work through some material together. There'll be some, especially at the start, there'll be some bits with more talking, that more lecture-like, where I'm giving you information. But then it's very much about the practical skills and doing things. So we'll typically, I'll take a command in the terminal, show how something works, and then ask everybody else to do the same. And we'll try and make sure that people are keeping up. But please do interrupt, put your hand up, ask questions, whatever you want. If anything needs more explanation or you're not sure of things, there's a hands up button in the interface at the bottom, the web interface at the bottom, or you can put your mic on and just shout, or you can just type something in the chat, and either I'll answer or both Jeremy and some other helpers are here as well, and they might help, and they could chip in and help you as well. I'm also going to put a link to the course materials, which you can see on my website, in the chat. It's useful to have them open locally, both because it may be a bit easier to follow along than trying to read it on my screen share, but also because it allows you to copy and paste commands into your terminal window from the work we're doing as we go along. And finally, on this, there's also a shared notepad associated with the course where we can add useful information. You can also ask questions here if you want, so people can answer them. But as things go along, if people ask questions and the stuff isn't in this sort of standard material, then we'll likely put it in here for future reference. And this pad is kept for after the course, so you can just generally come back and refer to it. What we do at the end of the course, in terms of both the recordings of these sessions and the pad, is we do some work to anonymize the contents of it before we put the videos up and before we put release the pad and archive it for posterity. So don't be afraid of typing things or asking questions, because we will work to anonymize the videos and all those sort of things before they go up on the ARCHER2 website. So that's the other point. We're being recorded here, and they will go up on the ARCHER2 website after the training. So if you want to come back and look at something, or you missed something, or you had to pop out, then you can always come back and watch the videos and get access to the bits you missed, or review something that you want to go over again. Finally, before I actually get started with the teaching, there's a draft schedule down here for today, and there's one for the course materials for tomorrow as well. What I'll do today is we'll work through the material. I want to make it as useful as possible to all the attendees that are here, So I'm not going to stick very strictly to the schedule. If some bits take longer because people have questions or we're going more slowly, that's no problem whatsoever. We've got plenty of time in the day. If we go a bit faster, that's because people are flying through the material and are happy with that, then that's no problem either. What I will guarantee, though, is we'll stop for lunch and restart again in the afternoon at the guaranteed at the time that's on the schedule. So we'll definitely stop at 12:15 at the latest for lunch, 12:15 UK time, and restart again at 2 o'clock UK time. I find that if we set lunch now and stick to it, no matter where we are in the material, it makes it easier for people to plan their day and make sure they can get a good break, because being online for a whole day is pretty challenging mentally and exhausting. So like I say, we're going to go through the material. We've got plenty of time, so please do ask questions as we go along if things aren't clear or you have something that wants clarified. You want clarified. It's no problem to ask questions on stuff that's in the future of the course. If I know I'm going to cover it later on in the course, I'll just say to you that we're going to cover it later, and hopefully that'll answer your questions then. But if it's something that's not covered, then I'll try and answer it at the time, and help us might try and answer it. If you end up running into problems with your Docker installation, there was a few emails went around where people was, there was a few tasks that people were supposed to complete before we started on this setup section. One of them was installing Docker locally on your system. Then the helpers are here to help you out. We have a few breakout rooms, so if you're really running into problems and we can't fix them just in the chat or in the general session, then we can take you out to a breakout room, share screens, and get the problem fixed for you, hopefully, so you've got Docker up and running. This course is really aimed at people who've not really used containers or have very little experience with containers or no experience with containers. We're not going to go into any super complicated advanced usage. We're going to introduce container technology through Docker in the first instance, give you some ideas of how to use it in different ways and the basic functionality. And we hope that it's a stepping off point for people. It should give you enough that when you go and read more advanced stuff about containers around the web or go on to more advanced courses, then you've got the background knowledge to be able to understand those things and use them more usefully for your work. Okay, so with that, I'm going to get started on the introduction, which is in the first instance a lot of me talking, but don't worry, it does get more interactive as the day goes on and we start doing more stuff with Docker, but we do need to set up some basic terminology and basic understanding first. So that's where I'm going to start with the introducing containers section. Before I do that, does anybody have any concerns or questions before we get started on the material and what I've said so far? Nope, I'm hearing all quiet. So we'll get started and work on things as we go through. So introducing containers. So what we're going to try and do here in this session, in this short introductory session, is actually look at what is a container, what we're talking about here, and how are they defined, and understand why they might be useful for people, particularly working in a research context. We're quite focused. Well, I know a lot of the material on the web around containers is focused more on sort of enterprise IT side of things. Serving websites, building web services and things like that. But this course is much more focused on people doing research and how they might use containers to solve some of the problems that they're interested in, some of the particular problems that arise around using software and computers within research. There is, as well as the material we've got here, there's a video, a short introductory video about Docker containers from the Australian Research Data Commons people. You may have already watched it. If you haven't, it's worth watching. Not right now, but I guess either after the course in some spare time. It will help reinforce what we're talking about here. So the first thing we'd usually do, especially if we were in person, was have a bit of a chat in the room about challenges that people have experienced using scientific software or software in general for their research. That exercise doesn't work so well, we found, in the virtual environment, or it's more difficult to do in the virtual environment. So I'm going to sort of skip over that, but I mean, bear that in mind. What I would say is throughout all of this introductory stuff and throughout the rest of the work we're going to do today, it's worth keeping your own particular research use case in your head and trying to think about how the things we're talking about might apply there, or the problems you've seen that maybe containers can help out as we go through. So yeah, try and keep in the back of the mind how this fits into your research, and please feel free to ask specific questions about where it fits in with your thing, and we'll do our best to answer them as well as we go through. So some of the typical things that people challenges people run into using software or scientific software are things like, you want to use some software that doesn't exist for your operating system. I'm running on a Mac, running from Mac here, and there are certain bits of software that don't exist for Mac that I might want to use. Maybe they're specific to Linux or specific to Windows or all those sorts of things. And I can't get the version or the software on my Mac system. Jeremy's just shared all the links again. Thank you for that, Jeremy, because people can't see the history of the chat if they've joined after we shared links before. You may be struggling to install a software tool because you have to install a lot of other things to get it to work in the first place. So these are called dependencies. Those dependencies in contain from other things, so you end up with this real explosion. You thought you wanted to install just a simple piece of software, and suddenly you're in this big horrible thing where you have to install lots of different things to actually get it working, which you just end up with. You want to get on with your research really, rather than spend your time fighting with the computer and with the software to get it installed. The software setting involves these dependencies, and only a subset of those actually work as desired. So you get this problem where things aren't quite working as you expect, or people have installed it and then it doesn't work as they say it should. You're not actually sure in the end what versions of software or their dependencies you're using, because the whole thing was just a bit of a mess installing. So you tried lots of different things and you end up with something that's working, but you're not quite sure what version it is, or quite how to get that working environment back again. You and a colleague may be using the same software but get different results because you've installed different versions, or using different operating systems or different processor technologies or whatever. It can be very difficult to understand and debug those sorts of problems. Everything's correctly installed on your computer, but now somebody else needs it, or you need it on a different computer where you maybe don't have quite the same privileges and it's a different operating system or a different setup. Or you've written a package for other people to use, but people really find it very difficult to get up and running. It's very complex to install, maybe because it has a lot of dependencies, or because it has very specific dependencies on specific versions of underlying software. And a final one, which sort of harks back to the title of this course, is you need to reproduce some research from a former colleague or from somebody else. And the software they used is on a system you don't have access to anymore. So suddenly you've got this challenge of, well, what actually did they do? Which version of software? Why are the results I'm seeing different? Is that because something scientifically has changed, or is that just simply an artifact of software changing under the hood? And almost all of these characteristics, I hope, as I've discussed them, you'll see is essentially become are really some sort of manifestation of the same underlying problem, which is the dependency between different bits of software. So the main software program you want to use depends on many other different bits of software in your system. And this can create a very complex, often fragile setup where one change and lots of things, you make one change to an underlying thing and lots of things break. I mean, most of us have experienced this. You upgrade your OS, there's a standard upgrade available, you upgrade your OS, and then things just don't work as they used to before you went through the upgrade. There's a classic example of this. And this situation is often referred to as dependency hell. And it's a real problem particularly for research, because in research, what you're trying to eliminate is the number of control is the number of things varying at any one time. And you need to be able to, in some sense, be able to reproduce the results consistently to understand where you are, and then to be able to change things in a controlled manner and see how those changes affect the results, right? I mean, that is essentially what research is controlling the changes and understanding the impact of different changes. So again, there'll be an exercise here, usually in a room, where we think about how the software challenges we've discussed just above have impacted your work. I mean, I would say that it's a useful thing for you to reflect on is where you've met these problems in particular in your work. Most of us have a story during the research work or work with software where they've seen this sort of problem and it's reared its head. And in particular for a research focus, these negative consequences show up as things such as you can't use a specific tool at all because it's not available or installable. You can't reproduce your results because you're not sure what tools you're using. So you can't even reproduce what you did a few months ago, never mind reproduce what somebody else did. You can't access new resources because you can't replicate your software setup. So that's, I'm stuck with this old system. I really don't want to upgrade the OS because, or things like that, and use new features of software, because if I do, the bit I've already done is going to break and I can't get it back. And other people can't validate or build upon your work because they can't recreate the unique configuration you had and end up with the same sort of results. So thankfully, there's ways to get around all of this sort of mess. And the thing we're going to talk about here particularly is containers and the use of containers to solve this sort of problem. And well, what containers essentially do is provide a way to package up all the software dependencies and all the way you've configured the work you're doing with software into a package that you can distribute to people to run themselves, or you can keep yourself to replicate in the future. So I've said containers here as a way to do that, and I think I've provided some sort of initial definition of what a container is trying to do. But let's think a bit more detail about what a container, let's talk a bit more detail about what a container actually is and what Docker is and how it relates to containers in general, because I haven't really mentioned Docker itself, which is the focus of today. So Docker is a tool, a piece of software, again, that allows you to build what we've referred to as containers here. It's not the only tool out there. In fact, tomorrow we're going to look at another one. We're going to look at Singularity. But it is the one we've chosen for the workshop today. But what is a container? So to be able to understand what a container is, we need to have at least some sort of understanding of what a computer is. And I want to make, I know this is really basic stuff, but I just want to make sure we're all on the same page and understanding where we are in terms of describing these terms, because it is important for the rest of the course today. So your computer has some standard bits and pieces in it that allow it to work. What's called the hardware, that's the physical things the computer's made of. One of these things is a CPU, often referred to as a processor. Processor nowadays may have multiple cores. So you'll see the terms CPU, processor, cores, and occasionally even socket used interchangeably. But essentially, it's the bit that does the processing and the actual calculation in the computer. There's an amount of memory, also called RAM, the computer uses to store information temporarily while the CPU or processor is working on the problem. So it gets its data from RAM and then works on it and puts the results back in to RAM, essentially. Okay, and there's also what's called the hard drive, though it can be lots of different things. The storage, the long-term storage on the computer, where you store information which either isn't being actively worked on by the CPU and persists when the power is taken away, which is the difference from RAM. Right, if you switch the power off, RAM loses all the data that's in it. All these pieces of hardware work together to do the computing. We don't generally see them because they're usually hidden from view. I mean, you will occasionally look in the task manager, see how much RAM memory you're using, how much load there is on the CPU, and things like that. But generally, we don't concern ourselves with what actually physically is the processor and what is the RAM underneath. Instead, we see our software, the desktop, the program windows, different folders and files, which live in what's called the file system. Everything on your computer, programs, pictures, documents, the operating system itself, such as Windows, Mac, Linux, lives somewhere on the file system, which is somewhere on the hard drive. Now, when you want to install some new software, but you don't want to take the chance of making a mess of your existing system by installing a bunch of additional stuff, such as libraries, drivers, dependencies, etc., you don't want to buy a whole new computer because that's just a mad, wasteful solution, both in terms of cost to you and in terms of the raw materials and the environmental impact to have a different computer for different software setup. But people have done this in research in the past. They've kept the creaking old Windows XP laptop running because that's the only piece of hardware that the software will run on. That is not an unheard of thing in research. But you don't really want to buy a whole new computer. So what you want instead really is another independent file system and running operating system that you could access from your main computer and that's stored within it. So you can think of this as a virtual computer within a computer. So to give a more concrete example, though not an entirely serious one, you can imagine you had two tools you want to use in your groundbreaking research on cat memes. So perlolling, a tool that does really well at predicting the best text for a meme based on a cat species, and WhiskerSpot, which is a tool, the only tool available for identifying cat species for images. You want to send the cat pictures to WhiskerSpot to identify the species, and then put the species output into perlolling to identify the right, to choose the best meme. But there's a real problem here. Perlolling only works on Ubuntu, and WhiskerSpot is only supported for OpenSUSE. So you can't have those two operating systems very easily on the same system and interacting with each other. Actually, we really want another file system or two on our computer we use to chain together WhiskerSpot and perlolling in our pipeline, right, in a research pipeline. And container systems like Docker are the special programs on the computer that make this possible. The term containers is probably comes from shipping. So in the old days, before containers were developed, packing and unpacking cargo ships was a really time-consuming and very specialist job. You know, a dock worker was a very highly skilled jobs, and they would specialize often in different types of unpacking in different types of ships, depending on what they were carrying. And there was a high potential for things to get mixed up and all that sort of stuff. So shipping containers were developed to keep things together in a standard package that everybody understood what size it was. You could design the ships around the standard shipping container. You could design lorries around to deal with standard shipping containers and trains and all that sort of stuff. And you could easily track what was moved around. So just as the shipping containers standardized how things, how goods are shipped around the world, software containers standardize the description and creation of a complete software system, including the operating system and the file system and all those sorts of things. You can drop a container into any computer with container software installed, called the container host, and it should just work, right? There are limits to this, but that is the sort of theoretical basis of containers, is that you have this standard package you can take anywhere and run it, and it should just work. So you may have heard of virtual machines and things like that. The containers are another example of what's called virtualization. That's having a virtual computer running and accessible from a main or host computer. Other example, like I say, is virtual machines. A virtual machine typically gets a whole copy of the operating system and the underlying operating system kernel, in addition to its own file system, gets booted in the same way a computer would. So, for example, that gives you a way of running a Windows kernel on a Mac system. You could boot up a version of Windows within a virtual machine. And containers are really much more lightweight. And what containers do is they share the operating system kernel, and so they typically only run on one type of operating system, and it's usually Linux. So a container is much quicker to start up and shut down and use, and the distribution of the virtual of the actual packages that describe the virtual machine we're talking about here are much smaller for containers than they are for virtual machines. So virtual machines are a whole different topic. We're not going to talk about them today. We're going to focus on containers, and specifically Linux containers. So you typically can't run, for example, a Windows container on a Linux system or things like that. All containers are generally Linux systems to a first approximation. And a final term, so while the container is the alternative file system layer you can access and run from your computer, the container image is the recipe or the template for the container. And we'll talk, I'll try my best to be consistent in using these terms throughout the course of the term container and container image. I may sometimes slip up, and I may sometimes just say image instead of container image. But what I do mean is the container image. And that's the template for creating an individual instantiation of a running container. The container image has all the required information to start up a running copy of the container. A running container tends to be much more transient and is started and shut down. And the container image is much more long-lived, like as the definition of the container. So you can think of the container image like a cookie cutter. It can be used to create multiple copies of the same shape or container and is relatively unchanging, whereas the cookies come and go themselves. So if you want a different type of container or cookie, use a different type of container image or cookie cutter. Okay, so that's that sort of very brief introduction to what a container and container image is. If you think back to some of the challenges we described at the beginning, the many layers of software installations making it hard for reproducibility and reliability and things like that. But if you think now about what a container is, a self-contained, complete separate computer file system, the advantages to putting your scientific software into containers are hopefully at least reasonably obvious in some cases. There's several problems that could be solved here that we discussed above. In terms of documentation, there's a clear record of what software and software dependencies we use from bottom to top. You'll see why later on when we talk about particularly Dockerfiles, which create a record of how you install the software to create your container image. There's portability. The container can be used on any computer that has Docker installed. Doesn't matter whether your computer's Mac, Windows, or Linux based, and I expect that we'll have various attendees today. Some people will be using Windows systems, some people using Mac, and we may even have some people who have Linux as their base operating system. We'll all be using the same containers across those different operating systems, and the idea is it should just work. There's reproducibility. You can reproduce exactly what you did before in the same piece of software and environment on your computer and on other resources. So you should be able to take that container and say your computer breaks, you start up you get another computer, you install Docker, you can take your container image and run exactly the same containers on your new system than you had on your old system without having to go through all the hassle and trying to get exactly the same software environment set up. And it's more configurable. The containers can be sized to take advantage of more resources, memory, CPU on large systems, on clusters, or less, depending on the circumstances. Depending on the problem size you're treating, you can expand or contract the amount of resources that your containers are using, or you can run multiple copies of them, for example, on an HPC system, maybe we'll see tomorrow using Singularity, or on a commercial cloud like AWS or Google Cloud, things like that. Say you wanted to run 1,000 copies of your container, you can do that concurrently on those sorts of resources and expandable. So the rest of this workshop is going to show you how to download and run containers from pre-existing container images on your computer and how to create and share your own container images. Finally, there's a few different use cases you can imagine here, particularly in a research context. You could use containers solely on your own computer to use a specific software tool or test out a tool, and possibly to avoid difficult and complex installation processes. You can create a Dockerfile, which is the definition of how you could create a container image with software that you specify installed, and then you can share that container image with other people who you're collaborating within your research to make sure you're all working in the same way. But you can also archive the container images you create, and including potentially the Dockerfiles as well. So you can repeat analysis modeling using the same software configuration in the future, capturing your workflow. So that can be very useful for yourself when you come back a year later and like, how did I generate those results? Oh, I've still got the container image. I know what I've done. Yeah. So the key points hopefully you've seen here are that almost all software depends on other software components to function, but these components have independent evolutionary paths, and that makes it very sometimes that can cause the real problems in terms of getting things up and running and maintaining a coherent environment and understanding what you're actually doing. Small environments that contain only the software is needed for a given task are easier to replicate and maintain. These are the containers and container images that we've been talking about. Critical systems that can't be upgraded due to cost, difficulty, need to be reduced on used systems and maintainable in a self-documented way. Hopefully container images can solve that. And virtualization allows multiple environments to run on the same computer. Containerization is a specific form of virtualization that improves the efficiency because it does not distribute the whole operating system. The containers share a kernel with the host system, an operating system kernel. And the containers are built from recipes that define the required set of software components and instructions necessary to build, install, and create images. And finally, Docker is just one software platform that can contain containers and the resources they use. We'll see another one tomorrow. We start with Docker because it's by far the most widely used around the world. And you should, by the end of today, have a working installation of Docker on your local system that you can then go away and use, and you'll have the tools to understand how to use it. So We're going to go on now to check we've all got a working Docker installation and check we know how to use it before we start doing the more advanced stuff later on in the course. While I do that and switch to the next thing, please feel free to ask any questions you have on what we've talked about so far, or let me know if there's anything that I glossed over too quickly for you don't quite understand, or you want me to go over again, and I'm happy to talk about that again before we move on to the next section. Yes, Mohammed, you have a question. You can either unmute and ask, or you can type in the chat. It's up to you.
Hi, you can hear me, right?
Yeah, I can hear you fine.
Thank you. Thank you for this intro. That was much needed. So I'm just kind of unsure, or maybe I missed this part. Like I'm never clear on the difference between Dockerfile and image, and how's image different from the Dockerfile?
Okay, yeah. So hopefully that'll become clear as we go through the day. But essentially, the image is the thing that is used to create running containers. So it's the binary thing, the binary artifact that Docker uses as the template for creating new images. The Docker file is the description of how you create the container image. Okay, so it's a three-step process. From the Docker file, you can create the container image. From the container image, you can create running instances of the containers. Okay, so the Docker file is essentially a text file that defines how the image is built, and then that image is used to instantiate running containers. I think it'll become clearer as we actually do the work, and we're going to later on in the day we'll create our own container images using a Docker file, and hopefully that will clarify it for you. If it's still unclear,
I
ask
think
again
Andrew,
later.
it is straightforward that like a bootable image of Windows or Linux. Same, I think the Dockerfile creates. So you have to just load the image and the container will start running, right?
Yes. So the image is the image is used to start the running container. The Docker file is used to create the image.
Yes, like a bootable image of Windows or Linux. We just insert the disk in the hard drive and start loading the OS. In the same manner, the image of the container will start work.
Yes. I think that's right. The thing I'm struggling with there, I think, is what the analogy for the Docker file is for that bootable image. That's certainly the container, the bootable disk. The bootable disk is like the container image of it, but I'm not sure how the Docker file fits into that analogy exactly.
Thank you. Yeah, I'm still new to this, so I'm still like trying to get around the terminologies and everything. So sorry if that was a naive question.
No, it's not. Any questions are really good. It is complicated, and it is difficult to get your head around the terminology a bit. Hopefully, one of the ideas of the course is by using these things, it clarifies it. But if you're still not clear as we go through the course, please do ask again, and we'll try and tidy it up for you.
Perfect. Thank you.
Okay. So the next step is to make sure, sorry, is there somebody else asking a question?
Yes, sorry. Hi. So maybe I have missed that part, but so in an HPC system, to be able to use containers, would the Docker be installed system-wise by means, or can we install Docker locally?
Okay, so typically on a shared system such as an HPC system, Docker wouldn't be installed, and you wouldn't be able to install it yourself. Okay, so this is one of the reasons why we talk about Singularity tomorrow, because typically on an HPC system, you'll see a different piece of container software. There are various ones. Singularity is one. There's a thing called Charlie Cloud, and there's various others. But for one of the reasons that Docker is not used is because to be able to use Docker containers, you have to be able to have administrator privileges. So on a Linux system, that means root access. On a Windows system, it means admin privileges. And a typical normal user on an HPC system does not have those sorts of administrator or root privileges. So a different solution is needed, which is why Singularity and other container systems are used on shared resources like that. Now, as you'll see tomorrow, Docker and Singularity are quite interoperable. So if you've created a Docker container, then you can pull that and convert that automatically to a Singularity container and use it on an HPC system. In most cases, that's very straightforward. So learning Docker isn't a problem. It's still a useful thing, because you're still going to have access to a privileged system to be able to build containers, right? So you can't build Singularity containers on an HPC system generally either, or from scratch anyway. You can build them from pre-existing Docker containers, but you can't build them because you don't have administrator privileges. So you still need like access to your local system where you've got admin privileges to be able to build the containers that you then take to the HPC system and use there. But we'll talk about that in more detail tomorrow when we talk about Singularity.
Yeah, thank you very much.
Okay, so this next session, we're going to have a quick look at the Docker command line. We're going to learn some bits and pieces, but one of the main outcomes here is just to check that everybody's got a working Docker installation on their system, and that it's all set up and ready to go for use later on as we go through the course. So the first thing you want to do is start the Docker application on your whatever system you're using here. If you're using Linux, then the installation of the Docker applications, your startup process, so there shouldn't be any need to do that, and it might do that for Windows. But so if you tick the right option at Windows or Mac when you install the Docker desktop, it'll start at startup time as well. I can see that it's already started on my system because it's quite hard to see, but there is a little icon up here. Sorry, I'm going to click on it on my screen. That looks like a whale with boxes on, a stylized whale with boxes on its back. And if I pull that down, it tells me the Docker desktop's running. So I think in Windows, it's in the sys tray. On Mac, it should sit in the icon bar at the top. And in Linux, it should, if you installed it properly, just have worked. Now, it may ask you to log into the Docker Hub. We're not actually going to do the Docker Hub stuff in this particular bit of the course yet. But if you want to log in, you can do. But if you can't log into Docker Hub, we can deal with that when we get to the Docker Hub side of things. So once your Docker application is running, then the first thing we're going to do is open a terminal or PowerShell on Windows, a terminal on Linux or Mac, or PowerShell on Windows. And we're going to just check it's all working by typing the command Docker and then giving it the -- version command option. So let me do that on my system. So I can do Docker -- version. And it should, if Docker is working properly, come back with a thing that tells you it's a certain Docker version and a certain build. If you get an error that looks like cannot connect to the Docker daemon or something like that, then there's something wrong with the installation. We need to look at that and get some help to get it up and running for you. So I'm going to give people a minute just to get that working. I'm going to put up a poll where people can respond whether they've got that set up or not, and that'll give me an idea of where everybody is in terms of their installation and who needs help. So just bear with me a moment while I put the poll and. So let's start that poll. So yeah, we'll give people a couple of minutes to check that works, and we'll see where we get to in terms of response for the poll. Yes, I should have said that. Thank you. Thank you, Jeremy. So if you have any problems or things aren't working, please say no in the poll or put your hand up, ask for help in the chat, and one of the people or somebody will come and help you out. But I think we're very close to it. There's only a couple of people who haven't answered, and I don't know if that's just because they're not here or just because it's taking a bit longer for them to get up and running. Sorry, I'm just going to have a sip of water because my mouth's a bit dry. Okay, I can see that everybody except one person, I think, has said yes. So what I'm going to do, since most people seem to be there, is I'm going to move on for the moment. It's Declan who hasn't replied yes. Declan, if you're having problems or it's not working, or it may just be that it's taking a little while to get it up and running, or your systems have to reboot or something like that, that's fine. If you're having problems, please let the chat know, and one of the helpers can come and take a look with you and try and work out why it's not working. I'm going to stop the poll for now and get on and move on with the material. But that all seems all quite painless, much more painless than it often is at this stage in the course. Okay, and we can try the Docker container ls command. My one will just a minute. So container, and we'll explain what these commands actually do as time goes on, just to make sure all the commands work. So the Docker container ls shows me that I have no containers running at the moment. It's just an empty list. Okay, and if you've got a newly installed version of Docker and you haven't done anything with it yet, this is exactly what it should show. Okay, if you want lots of information about how Docker is configured, you can use the Docker system info command. Produces lots of output, but a lot more output than we've seen before. But there we go. If you get, like I say, if you're getting this sort of message, then please ask for help in the chat, and we can come and double check what's going on there. So that's on a Linux system. So if you're in the Docker group, it shouldn't require sudo. So it sounds like something in the configuration is slightly wrong there. I mean, you can just do the whole. You can just work through the course and put your sudo in front. But if you want, just let us know. We can have somebody come and take a look with you. It sounds like the configuration is slightly off, because if you're in the Docker group and it's all configured properly, you shouldn't need sudo, I don't think, to be able to run those sorts of commands with Docker on a Linux system. It's weird. The configuration of Docker is strangely much easier on Windows and Mac compared to Linux generally. Even though Docker is essentially a Linux tool, there's a lot more pitfalls if you're running it on Linux than if you're running it on Mac. Yeah, and Jeremy's suggestion is a good one. If you've not done a restart of the term, if you've not restarted a new shell since being added to the group, then you do need to do that to pick up that option. Oh, thanks, Jamie. That sounds like a useful suggestion. Okay, so getting help from Docker. Most people who've used Linux or command line before are pretty know that the standard way of getting help is to add the -8, the -help or -h flag to a command. So Docker's no different. If we want to get information on how to use Docker, we can use Docker -help, or you can look online, obviously, for documentation. But sometimes it's quicker just to get the help in the terminal, and that gives you a list of the different sorts of commands and different sorts of options Docker can take. Okay. And if you want to help on a specific command, rather than just Docker -help, say we used Docker container before and I used ls, but if I do Docker container -help, it'll show me the specific help for the Docker container command. You can see that ls is one of the extra options there that is the one we use to check things were working properly. Okay, so you can always get help. As you get more familiar with Docker, the help gets more and more useful because you start to understand the terms better and better. And like I say, you can keep going down the levels, right? So Docker container. Sorry, you will get used to the fact that I cannot actually type at all, and so I will make mistakes with my typing. And you can keep going down, and you get more and more focused in help as you go down the command. So this is often the quickest or most easiest way to get help with particular commands. If you want more detailed help or examples of how to use the command, then often online documentation is a better way to go. So there's many different commands from the Docker command, and you're not going to be able to remember them all. You will learn and get used, probably remember a small number of them, which are the ones you use most often: Docker container ls, so Docker container commands, Docker image commands, as you'll see later, and Docker build commands are probably the ones that people get most used to most quickly. But there's always going to be the odd command that you don't use very often, that you're not going to be able to remember the exact syntax for. And this online help is really useful for as a trigger to memory, is exactly what the syntax should be for such a command. It's generally faster to get the help from the built-in tool rather than going online. But the same is true of any tool, I think. So in this lesson, we're going to be the notes on syntax. There are different types of Docker command syntax around. We're going to try and use the newest Docker command line syntax that came in with the Docker Engine version 1.13. This syntax combines the commands into groups that you often interact with. So we use the container ls command and things like that. If you look online, you may see that slightly different syntaxes for achieving the same thing. There are legacy ways of doing things in there, so you may see examples of people using the older syntax when you're looking around online. That's fine, as long as you understand what the command's doing and what it's attempting to do. You can usually decode those things, but we will try and stick. We will try and do our best to stick to the new syntax throughout this course, as that's the one that's going to be supported by Docker going forward, and actually the one that logically makes the most sense because of the way it's designed. So there's a quick example, a quick exercise here for people to have a go at. Run docker -- help, pick a command from the list, and explore the help prompt for that command. Try to guess how the command might work from looking at the usage section. So it's just to give you a chance to explore using the help feature. We'll give you maybe 5 minutes to have a look at that. So we'll we'll start up again at just before 5 to 11. I think we're next is exploring running containers. Yeah. So so have a go at that quick exercise just for a few minutes. Pick a command, explore what it says in the help. Have a guess at how it might be used in practice. It's just to give you a chance to explore the Docker command and the help features. So I'll give you a couple of minutes to have a go at that. So, of course, if you've got any questions or anything on this quick introduction bit to Docker or anything you've heard, please do feel free to ask while we're doing this little exercise. I'm happy to try and help answer them.
Hi. So if you type Docker, it gives the same output with Docker -- help. But I guess this is not the case all the time, right?
So you mean if you just type Docker without any options?
Yeah.
Yeah, like that. Yeah. I haven't really explored that. Oh, so it does as well. So it might not do it in all cases, because some of the subcommands might not take extra options, so they might actually just do something instead of returning the help. It looks like if it's expecting more from Docker, so the format for Docker image is Docker image and then an extra command, but you haven't supplied the extra command, then it just prints out the help by default. But there will be some of the commands that don't require an extra command, so they might just do something instead of printing the help. You see what I mean?
Yeah.
Okay, so I'll pick out a few minutes. So for example, the example in the solution here is to have a look at Docker image build. So oops. We'll give some help at the Docker about this command, and from the usage here, you know, I would suspect that you know, the command could be run something like this with Docker image build, and then the path is dot, which means the current directory. Okay, or you could supply some sort of path or URL to somewhere that has the description of how to build that image, which in our case would be where the Dockerfile is. We'll see that later on in the course when we come to writing Dockerfiles and building our own container images. Okay. So, like I say, the main exercise of this very short session was just to make sure everybody's got a working version of Docker up and running, so we can go on to the rest of the course of impunity. But hopefully, the two other things you've seen as well, you can see whether it's ready to use from the toolbar icon. You typically interact with Docker via the command line rather than through a point and click interface, and also there's a pretty extensive online built-in help system that you could use to get more information on Docker and the commands you're running for as you go on. So we're going to have a quick start of the next session, but we won't get to the end of it. We'll just do some of it and then we'll stop for a break, a 15-minute break to give people a chance to go and get a drink and stretch their legs, and then we'll carry on with this session. So in this session, we're going to have a look at how we actually interact with Docker containers and container images on the computer, how we get hold of pre-existing Docker container images, how we download them, how we start running containers, and understand what they're doing. Reminder that the container image is the template from which particular instances of a running container will be created. So we're going to have a look at our first Docker container, and in the time-honored way for any sort of software and programming course, the container image we're going to look at is the hello world container image, because you know, well, who are we to break with 30 years of tradition in training for programming and software? So the Docker team themselves provide a simple container image online called Hello World. We'll start by downloading that and running and creating a container from that container image and running it. So as we saw before, the Docker image, sorry, we didn't see this one. The Docker image ls lists the container images that are already installed on your or already downloaded to your system within Docker. Now, if you've just installed Docker and not done anything yet, then it'll be empty. My one will have some images because I've done various bits and pieces, and I use Docker in my day-to-day work. So it's got, I've tidied it up a bit because this list was much messier yesterday, but it does have a few images there for the things I do. You can see, for example, I write some documentation as part of my job, so I have some containers that allow me to use the tools to write that documentation. But but you may not see anything listed if you've only just installed Docker. The first thing we're going to do is get a copy of this Hello World container image from the internet. So what we want to do is Docker image pull, and then the name of the container image we want, which is Hello World. So like that, Docker image pull Hello World. And I can't spell. Knew that happened. If you want to cancel a Docker command, you can just use Control-C, like many other commands down the command line. So if I spell it right, actually, it should do it. So what actually happened here? How did it know where on the internet to go and get this Hello World container image from? So it magically came from a place called the Docker Hub, which is a standard repository of container images that anybody actually can get a free account to share images with the rest of the world and allow them to be pulled and used on local systems. So when you don't tell Docker where you want to pull the container image from, by default, it goes and looks in the Docker Hub and sees if it can find something that matches the container image name that you specified. So this one magically went away to the Docker Hub. It tells you where it's pulling it from on Docker Hub. It's on the library Hello World, and then it downloads it for you. Okay, and what we can do now is, I guess you should be able to guess, hopefully, how would you now check that it downloaded successfully to your computer? Anyone got any ideas? Yeah, exactly. So Docker image ls, what we used before to show the images that are downloaded on your local system. And you can see before, I didn't have the Hello World one there, but it is there now. Okay. But it's not here in a container. Sorry, it's not here in the directory or folder that I'm in. Docker stores its images in its own repository somewhere on your system, and typically use the Docker command to interact with them and list them, remove them, copy them, all those sorts of things. They're not. There is a place where the files are stored, but it's typically not. In the directory that you're currently in, and it's in a central location. And it isn't commonly accessed directly on the system.
Sorry.
Yeah.
Sorry. Why does it show the creation date 3 months ago? We just created it.
So we didn't just create the image. So what we did was downloaded an image that had been created by somebody else.
Okay. Yeah.
So that person created that version of the image 3 months ago, is what that's telling you, and then put it up onto Docker Hub for other people to use and pull. Okay, so it's not like a file creation date on your system. It's actually the creation date of the image itself. Jamie's asking if the images are stored per user or system-wide. I think it's per user, but I haven't tested that because I'm the only user on my computer. So I would have to go away and look. I don't know the definitive answer to that question. I don't know if Jeremy does off the top of his head, but I have a feeling it's per. My instinct would be it'd be per user, unless you specified otherwise. I wonder if there's an option where you can say it's available to everybody. Don't know. Have to look that up and see what it is. I can look that up during the break and see and get you the definitive answer to that. Okay, so we've downloaded it. Now the next thing is we're going to actually use it. We're going to run a container based on the Hello World container image. So this is using the Hello World cookie cutter to create a cookie, Hello World cookie in our cookie cutter analogy. And you may be unsurprised to know that the command for running containers is docker container run. And then you give it the name of the container image you want to use. Okay, so let's try that. Docker container run, and it was Hello World. See if I can spell it properly this time. Okay, and that ran successfully. So what this container image actually does is it runs the container that prints out a message and then stops. Okay, so in description of what just happened, when we used the docker container run command, Docker does the 3 things. It started a running container based on the container image. This is the sort of alive or inflated version of the container. It's actually working and doing something. Okay, so this is the container based on the container image. If a container has a default action, or a container image has a default action set, it will perform that default action. So in this case, it's very simple. It prints a message. That's all the container is designed to do. Or it could be much more complex. It could run a whole data analysis pipeline or something like that. Okay? And then once it's finished, once it's done its default action, it shuts down the container and stops. It or stops running, or what's called exits. The container image is still there, but it's not actively doing anything, and it's not running. And you get access back to your original command line. And the whole Hello World container is set up to run an action by default, which is to print this image. Okay. sorry, this message back to your screen. That's all this container is ready. And I mean, it's not that surprising. It's only very small in size. It's just 9K, this image. So it obviously doesn't do anything very complicated. It doesn't have very much data in it. Now, one thing to note is we could have skipped the Docker image pull step. If you just use Docker container run and given a container image name that was not already installed locally, then Docker will automatically try to pull the image first and then run it straight away. So you can just do this in one step. Okay. Before we go on to the next steps, which is doing a bit more complex stuff with containers and container images and understanding how maybe I get a bit of a feel for how they work and what's actually going on. It's 11 o'clock and I think we should stop for a break. We've been going for just about an hour now. It would be useful for people to tune out for a minute because it's challenging online. So what I'll say is we can start back at 11:15. That gives you almost 15 minutes for a break to get a cup of tea or coffee, stretch the legs and those sort of things. So I'll stop there for a moment. I'll stay here. So if anybody's got any questions, please feel free to ask them. And we'll start again with the rest of this, the material again, the course material again at 11:15 UK time. Okay. I'll put up a poll to check that people are back. So you can leave yourself connected to the session if you want, and I'll make sure that people are back before we get started again. But if you've got any questions on what we've done, the small amounts of stuff we've done so far, then please do ask. Okay, so Lorenzo asks, I've successfully pulled the hello world image, but I haven't been asked for my Docker Hub login. Is that normal? So yes, it is. So images, a lot of images on the Docker Hub are publicly accessible. So you don't need to log in to get them. You know, anybody in the world can pull them without logging in. It may, of course, be that you're logged in by default. Often the Docker desktop, especially if you're running on Windows or Mac, will automatically log you into the Docker Hub when the Docker desktop starts. And so the login is not required anyway because it just sorts you out automatically. But you can always pull the image without having to log in. You can pull a public image without having to log in anyway. What you'll find is, as we go later on into the material, when we want to do the opposite, which is Docker push, where we've built a container image and then we want to push it up to the Docker Hub to share with other people potentially, or to keep a record of it for ourselves, and then you do need a login to be able to push up because you're adding something to the repository.
I just had a question about logging into ARCHER2. So
yeah.
I set everything up and went to go SSH into my username at login.archer2.ac.uk, and I used the initial password provided on the website and used that to reset the password. And so it boots you off, so you have to log back in. And then what I noticed is it seemed to be in an infinite loop of every time I log in with a new password, it says your password is expired and you must change it. And then it boots me off again, and then I have to do it again with a new password.
Okay, that's very odd, and that shouldn't be happening. Okay, that sounds like there's something we need to raise with the systems team for ARCHER2. There's something very weird going on there. Can you either, well, the two ways we could do this, either you can submit a service desk query yourself, or you can send me the details and I can submit it on your behalf. You can send me the details either by pasting them in the chat or put them in the shared document.
I can send them a message.
Yeah, please do. I'll make sure. I'll keep an eye on it and make sure it goes through, because obviously we aren't actually using ARCHER2 till tomorrow morning for the Singularity stuff. So we do have a bit of time to get that sorted before we get to that material.
All right, cool. Yeah, I'll put that in. Thank you.
Great, thank you. Sorry about that issue.
Yeah, no worries.
I was just going to say, Andy, whether is it worth one of us just checking in a breakout room just to see what's happening there, or whether we can sort of see any more. But I guess it's, as you say, it's probably a system problem. But
yeah, from the description of the problem, it sounds like there's not much we could do on this on the client end to help. That we think.
No problem.
Yeah, you said you wanted to jump into a breakout room, or?
I mean, I can have a quick look if I mean, I'm not an expert on it, but if you want just somebody else to sort of look and see that there's not some sort of something.
Yeah, I guess the only thing it could be that we could help out with is somehow that the password isn't being reset successfully. You know, the new password isn't being set successfully, so every time. So
I can confirm it definitely is being reset each time, because
okay.
When it asks, in order to reset your password, you have to put in the old one. And
Yeah.
Is the one that I set before each time.
Okay. So that sounds like a system problem. So I think we will need a query for that. I don't think there's much we can do from our end in terms of a breakout room.
Yeah, and I'm also on a Mac OS. I don't know
Yeah.
if that's relevant.
No, well, I'm on Mac OS as well, so obviously, so it usually works fine. We can double check. That sounds like something at the systems level, I think.
Yeah. Okay. Cool. Thank you.
Lorenzo, in terms of whether Docker's logged you in at the time of installation, if you look at if you're on Mac or Windows, then looking in the icon bar or the sys tray. Oh, you're on Linux. Okay. So you could type. It's Docker login, isn't it? The command. So, yeah, we'll get to it when we go to the Docker Hub episode. Let me have a quick look. Just double check the command. It's not one I issue very often because I'm usually logged in already. Oh, here you go. I'll use the Docker help, as I said I should in the first place. Oops. Yeah, so if you just type Docker login on Linux, it should ask you for your Docker Hub username and password, assuming you've set those things up already, and then you can check. You can see if you're logged in. How you test whether you're logged in from the command line, I can try and find out. Give me a second. Okay, Lorenzo, a quick thing. I don't know if you're still there and listening or not. I'll type it in the chat as well. But actually, what Docker login and what logged into Docker means is actually not that you're actually logged in. So maybe we should update the material to do this. What it does is it just tells you if your credentials are stored, so that when you try to initiate a command that requires login, it knows what to do. Okay, so when you type the Docker login command, you type in your Docker Hub username and password, then it stores those credentials for in the future, so that when you try to do something that requires a login, it knows how to deal with that. Okay, so it's not actually really logging you in; it's just storing your credentials. And then if you issue Docker login and use a different repository, by default, it's usually the Docker Hub. But if you specified a different repository, it'd store those credentials for that repository instead. Okay. I'm just going to step away for a couple of minutes to get myself a cup of tea, but I'll be back in time and set up the poll for restarting in a few minutes. Okay. Hi, everybody. It looks like most people are back. Yeah, and most people are back, so we'll get started again with the Gregor says he doesn't see a Docker icon in the system tray. I don't think he, so with Linux, I don't think you expect to. I think that's only a Windows and Mac OS thing, because of the way they run. It's technicality of the way they run Docker in Linux compared to Windows and Mac OS is different, because Docker Docker containers are a Linux thing. What actually Windows and Mac OS are doing is running a Linux virtual machine, or a Linux virtual machine in the background, and that's what you connect to when you use the Docker commands. Whereas on Linux, because Docker is a Linux thing, it uses the native kernel, so it doesn't need that extra step of having the Docker what the application called the Docker desktop. It just runs natively. So this sort of virtual machine, which is the thing that appears in the sys tray, or the thing for managing the virtual machine, the images, which is the thing in the sys tray or the icon bar, doesn't appear on Linux. Okay, so we've done something very simple. We managed to pull a container image from the Docker Hub, and we managed to run it, and it did a very simple thing. It had a default action just to print a command back to the screen. But quite often we'll want to run things. Sometimes we'll want to use the default action of the container image or the container, but sometimes we'll just want to run a command in that container, or run something different, or do something specific. So we're going to have a look at how you might do that now. So this time we're going to try and run a different container called the Alpine. Alpine's a very a sort of a small version of Linux. Okay, so it reduces the download time as much as possible. So take the command, try downloading the Alpine container image and run it in container. You can do it in 2 steps or 1. Okay, it's up to you whether you do it just by using the Docker run command, or whether you do a Docker image pull. Sorry, a Docker container run command or a Docker image pull command first. I'm just going to use the Docker container run command and just show it downloading it by default. So Docker container run Alpine, which is this minimal version of Linux. So it tells me it can't find it locally, so it's going to have to pull it, go to the Docker Hub and pull it, and it did it, and pulled it, and when it ran, nothing happened. Is the container still running? Nope, no container is running at the moment. So, so the reason nothing happened was there's no default action for this container defined in the container image. So it wants you need to supply the command that you want to run. So we could see what we could do is run a command. So we're going to run this command, which is cat etc/os release. What this does is cat is just it just prints the contents of that file to the terminal. So I'm not going to type it all out. I'm just going to copy and paste it this time, because otherwise it's very slow. So if I do that, okay, so what it has done is it's done something this time. And what it's done is it's started the Alpine container, and then within the Alpine container, it's run this command. And cat is a Linux command that just prints the contents of a file back to the screen. And that file /etc/os release contains these lines of text. Okay, and actually they just define what version of Alpine Linux has been installed, is running in that container. So the question, the exercise here is, given that, could you use that Alpine container that you've just downloaded, is working, to make it print hello world in the sort of standard canonical programming example? I'm happy. I can let people have a go, or I'm happy for people to shout out if they think they've got the solution. Yeah, exactly. So you could use echo. So echo is a Linux command that just prints a string back to the terminal. So I could do the same, run the same container again. Run a container with, it's not the same container, run a container based on the Alpine container image and give it the command echo, oops, hello world. Okay, and that just tells, it starts up a container, runs the command echo hello world, and then stops the container again. Okay, so this is different from the hello world container image that we use because there's no default action set. So we have to supply what we want the actual container to do when we run it. Now, of course, you may not always, say I wanted to run multiple commands in a sort of fascist example. I'd wanted to run this command and this command in that container. Okay, in the running container. Yeah, you can use printf as well if you want as well. So I wanted to run both those commands. Now I could do it by running that and then that, okay, as we've just done before. But actually, what you're doing is running two separate containers. You start up a container, run that command, and then stop the container. You start up another container based on the same image, run that command, and then exit. If I wanted to run them in the same container, then I'd have to construct either a more complex command end, but I could also access the container interactively, and so get a shell and a command line within the container itself, which allow me to run commands. And to do that, we need to give some extra options to the Docker run command. And the commands we need to, this is the command we're going to run here. Okay, so this does a couple of things. One is, most of it's the same. Docker container run, the name of the image we're basing, the container image we're basing on, and then the command to run. This command here, sh, starts a shell in the container, which is essentially what I'm typing out here to give the command line. Okay, and then, but in order to get the shell and get access to it, so I can type it, I need to type at it. I need to add some extra options to the Docker run command, and these options are -i and -t. And in standard sort of Unix way, you can two options, you can concatenate them together into one -i. So instead of typing -i and then -t, you can just type -it. The -i means interactive, and the -t says give me a sudo tty. That means give me a terminal where I can type things at. Okay, so let's try this command and see what happens. So what you'll see is my prompt where I'm typing commands has changed. Okay, and it's changed because that prompt is now not on my host operating system, my Mac here. This is now the prompt for issuing commands to the container instead, or within the container. So I could type my cat etc os release and get the same output I got before. I could echo hello world and get the same output before. I could do other things. I could print my current working directory, which is / I can ls to list the files there. You'll see they're different from the ones that I had in the working directory I was in on my Mac, on my host computer. I can ask what user I am. I'm root. I'm a super user within this container. Okay, and there's lots of different things you can do. And then when I've finished typing commands in the container, I can type exit, and that takes me back to my host system. And you can see that ls is very different, and pwd is very different here. Okay. What happens if you execute the rm command accidentally within the container because you're a super user, right? So you can delete anything. Then actually, it mostly doesn't matter. It's certainly in this instance, it mostly won't matter because the container is a transient thing that gets stopped when you exit out. The time that could become an issue, you'll see later, we'll show you how you can mount data from the host system into the container. Then you could delete data on the host system accidentally if you type RM accidentally in the wrong place. But that's just the same as if you were working on the host system. You know, if I typed RM here, I could delete files that I didn't want to delete. Okay, but within the container itself, it doesn't matter because the container is only transient. So if you RM something, the next time you start running a container again, the files or everything will be back because you're starting a new container based on the image. Okay, so it's a clean slate. But you do need to be careful if you've made data available from the host system. So it says by default, you seems you're rooting the interactive. This is normal for Docker. Okay, so one of the things somebody asked about earlier was running Docker on HPC systems, and I said that wasn't generally possible because you had to be the super user or privileged admin user or root to be able to use Docker. So you in Docker you generally come in as the root user. There are options where you could use to change that, those sort of things, but that's beyond the scope of this course. Typically in Docker you're working as the super user. Okay, that's one of the reasons that it's not suitable for installation on shared systems such as HPC systems. Okay, when you'll see tomorrow, hopefully when we're using the Singularity containers, that you're not the root user, you're the same user as you are on the HPC system within the container. Roshan asks about where to save data generated in the container. We'll talk about, if you don't mind, I'll defer that question for a little bit because we are going to cover that specifically a bit later on today, and we'll talk about that then, about data, about saving data and making data accessible in containers and files and stuff like that. Okay, so we've got a quick exercise for you here to try and to give you a chance to try and get a different container and explore running commands in it. So what I want to try and do is find the BusyBox program in a container created from the BusyBox container image and find out what the BusyBox program actually does. There are two ways to do this. One is the interactive solution I've just shown you, which is to open a shell in the container that you're running and use that, or you can use it in the way we saw before by passing commands directly to the container within the Docker container run command line. I'll give you 5 minutes to have a go at that. So it's just about 11:30 now, so we'll give it to 11:35, and then we'll have a look at the solutions together. But try and see if from the BusyBox container image, if you can find out what the BusyBox program actually does. I'll put up a little poll where people can answer to see whether they've successfully completed the exercise or not. So I've got an idea of how far along people are. Okay, some people seem to have managed to have a go at that. So I'll kill the poll now and we can have a quick look at solutions and then deal with any questions from this exercise. So let's have a look at the interactive way of doing it first, or the interactive way of doing it. So I'm going to just put BusyBox in here instead. It tells me I can't find it locally, so it goes and pulls it and starts and gives me my shell. And is the BusyBox command program there? Yes, it is. And so BusyBox -- help, and you get a lot of output. Okay, so what? Somebody said they didn't understand what it did. BusyBox essentially mimics a lot of Linux commands in a very small program. So all these sorts of commands which you'd usually use on Linux, which are essentially different commands in Linux, so things like cat, which you've seen already, and I'm guessing echo's in here somewhere as well. I just have to find it in. It's in a there you go. It's in an alphabetical list. So it emulates lots of Linux commands in a small program, which means they can be put into small embedded systems that don't have much memory or much resources to work with. So people use BusyBox when they want to use Linux stuff on a small. Okay, so you can just run it without. So there's an interesting point from the chat messages sent in. Sorry, Ephemios, I'm probably mangling your name when I say it. When I say it, I'm not very good at pronunciation. So Ephemios says you could just use Docker run -IT BusyBox, omit the container and shit because they're invoked by default. Fine. So I'm happy with the omitting the sh if that to be invoked by default, but removing the container is what I mentioned before about the old syntax and the new syntax for Docker. So you're just using Docker run without the word container is the old legacy syntax for Docker, and it's just it's less verbose and not guaranteed to be supported going forward. It probably will because it's used so much. The old syntax is still used so much by people, but you can't rely on it. And as I said, we're concentrating on using the newer syntax here, which is a bit more verbose, but also is clearer what's actually going on. Okay, so the reason that you don't need the container is because you're just falling back on the previous version of Docker syntax there, not because there's not anything to do with this particular container image or anything like that. Okay. So Jamie, can I leave that question? I mean, maybe one of the helpers could help you out and explore that with you, but it's a bit of a tangent for the material, so I don't want to get bogged down in that at the moment, if that's okay. Anyway, so there are lots of other options to the Docker container run command besides -i and -t, which we've seen already. You can obviously get them via Docker container run -help. The couple that people use, reasonably often are --rm. Now, as we'll see in a bit, when we're managing containers, when a container finishes being used, it doesn't actually get deleted. It just goes into a stopped state. If you give Docker container run the --rm flag, then as well as stopping the container, it deletes it. And there's some useful reasons why you might want to do that. It doesn't delete container images; it just deletes containers. Is worth pointing. And you can give it a name as well. So by default, Docker will assign a random name and ID number to each container instance you run. But if you want to have an easy name to refer to it, you can define that when you run the container. So hopefully in this short session, we had the tea break in the middle. We've seen how to at least download and run container images that other people have prepared and made available on the Docker Hub. We've also seen how you can run commands inside running containers, either directly by passing the command we want to run on the Docker container run command, or by getting an interactive shell within the container. So next, we're going to take a look at the different kind of Docker container images that are out there. So this is just there's the break we had a bit earlier. That's fine. Oh, sorry, that's not quite right. So next, we're going to look at how we manage containers a bit more, how we keep track of what we've got, maybe delete things, and tidy up after ourselves. So container images and their corresponding containers can, over time, start to take up a lot of disk space on your system if you don't clean them out occasionally. So it's a good idea to have a quick look, like I did yesterday before I started this course, of what sort of container image junk you've accumulated over time, and have a bit of a tidy up of things you're not really actively using anymore. So in order to remove a specific container image, you need to find out the details about the container image, particularly the image ID. You can use the name as well, but but that can get more complicated. If containers can have names that are very similar, or even the same, but still have unique IDs. So it's generally preferable though not always as convenient to use the image ID when you're trying to delete and manage things. So you've seen before, we can get the list of images with the docker image ls command. So I can run that again, and you can see here there's this column with the unique ID for the different container images I've got on my system. So let's have a look at the hello world one. Let's try and remove the hello world container image. So if I find hello world, it's here. This one, so this is my image ID. So I'm just going to copy and paste that. So I'm going to try docker image rm and give it the image ID. Okay, I could also type hello world here because it's a unique name, but I'm working with the image IDs at the moment. So when I try to remove the Docker image, delete the Docker image to free up some space, I get a slightly weird error message that says I can't delete this because the image is being used by a stopped container, and it gives you the ID of the stopped container. See, I could have done that as well. Okay, so this is what happens when, as I mentioned before, Docker doesn't clean up previously running containers, it just stops them. It does this for efficiency reasons, because often when people are using containers, they want to use that container again pretty soon afterwards. Okay, so it just keeps them in a stop state so it can restart them quickly if you want them. But as we're now working with containers, rather than container images, we're going to look at containers, not container images. We're going to switch back to the Docker container command rather than Docker image command, and we could do Docker container ls in exactly analogous way as we did for the image. And you see that it doesn't show me any container images. Now, somebody mentioned this before in the chat. That's because by default, it only shows you running containers, not stopped containers as well. To show stopped containers as well as the running ones, we need to do the ls. We need to add the --all flag to the ls command. So let's do that. Oops, if I can type docker container ls --all. Okay, so you can see there's quite a lot of the ones, quite a lot of different containers here. Sorry, the reason it's extended slightly is because my terminal is not really wide enough to capture all the terminals. So you can see there's one hello world, quite a lot of Alpine images, and one busybox. Sorry, images. See, I knew I'd slip up as we went on. Quite a lot of Alpine stopped Alpine containers, and one busybox one. So in order to be able to in order to be able to delete the container image, I need to delete the stopped containers first. As we mentioned just a moment ago, you can add the --rm flag to Docker container run to automatically delete containers when they stop, if you want to. That's sometimes easy. So in exactly the same way as we tried for the image, we can remove a container with Docker container rm and then its image ID. Okay, so it's container ID. So let me grab the container ID for the hello world one, which is here. I could do Docker container rm and then the ID. Okay, and it pirates back the ID to me to tell me it's successfully removed that container. You can check that with the Docker container ls --all. The hello world one's gone. Okay, so now I could go back and remove the image because the stopped container is no longer associated. So I'm going to skip back to my command, which was Docker image rm, and then the ID for the hello world container. It's a hello world image. See, this is I'm not doing very well again. It turns right. And this time it did delete it successfully. And you can see the hello world one is gone. Now, if you just want to get rid of all of your stopped containers in one go, you can use the Docker container prune command. Okay, this removes everything and means that you can easily clean up images if you want to. So this is what I used yesterday when I was cleaning up quite a lot of stuff. I first issued a Docker container prune command. Are you sure you want to continue? I have to type yes. And it tells me it deleted all these containers. So if I do Docker container ls --all, oops, --all, You can see there's none of them now. So any of the container images I want to delete, I could do that now without worrying about this error message about Docker container, about the stopped containers. It depends on what you're doing. If you've got some big container images, then you might get some extra overhead in starting a new container from the fact that you're not using the stop prompts. But it should. But in general, I often use the --rm flag when I'm running a container to make sure it's tidied up properly when it finishes. Okay, so we removed the image. Yes, sorry, who's got a question?
Can I ask? So could you tell again what is the difference between Docker container ls --all and Docker image ls --all? Because when I issue the first one, it is pruned, it's clean. But when I issue the Docker image ls --all, I still see the images.
Okay, yeah. So the difference is the Docker container ls is listing containers. Okay, so that they're running or stopped instances of containers that are based on the container images. If you remember back to the analogy at the start, the container image is like the cookie cutter that tells you how to create a container. Okay, so you can have multiple containers created from one cookie cutter. When you saw my listing back up here, where is it? Yeah, it was this one here. You can see there are multiple containers that are associated with the Alpine image because I ran the Alpine. I issued lots of Docker container run Alpine commands. Okay, each time I issued that, I created a new container from the Alpine container image. Okay. So yeah, so the Docker container ls lists those instances you've created from images, and there can be multiple instances per image. The Docker image ls shows the container images that have been downloaded and stored locally on your system, which can then be used to create container instances.
Mm-hmm. Yes, thank you.
Okay. And that is this subtlety between, one of the challenges with the commands is they look very similar because Docker container image ls and Docker image ls and Docker container ls look the same. Now that's good because it makes it easier to remember the command because you just have to remember your operating containers or images and then add ls. But it is sometimes confusing when you're starting out because you have to remember exactly what the difference between an image is and what the different from a container. So that short section hopefully showing us how to manage our containers and our images. So you can list them. You should know how to list them, delete them, tidy up, and things like that. As I've said, the --rm flag is a really important, is a really useful one for when you do Docker container run, because it will automatically get rid of the thing at the end. In fact, I can show you that. Docker container run --rm. That's hello world because I've already. You just see me delete. You've just seen me delete the whole hello world image, so you know it's not on my computer. So it can't find it because I've just deleted it. So it doesn't get it from Docker Hub again. It runs it this time. So if I do Docker container ls -all, there's no containers there, even though I've just run the hello world one because I added the --rm flag. But if I do a Docker image ls, the hello world image is back. So I haven't deleted the image, I've just deleted the container when I ran a container based on the image. Okay. Fine. Is there any more questions on managing containers and images? And before I go on to the next section, which is a short section, a bit more about the Docker Hub. No? Okay. Fine. Sorry, just going to take a sip of tea. Okay, so we've been using the Docker Hub all the way through the lesson so far. Whenever we've ran or whenever we've pulled an image or ran a container where we didn't already have the image downloaded. It went away. The system Docker went away to the Docker, pulled those images for us, and then ran the container. Dockerfile actually is just a very large online repository of container images. A large number of them are publicly available, so you don't even need to log in to Dockerfile to be able to access them. And some of them are just created by individuals. Some of them are created are official images from particular teams and groups of people for commonly supported things. And many commonly, you can find on there many commonly used pieces of software that have been containerized into images. And some of them are officially endorsed, which means you've got more trust that the container images have been checked for functionality, stability, they don't contain malware and won't cause problems for your computer. And I should point out that while Dockerfile is well integrated into the Docker command by default, it's not required to use Docker containers, and it's not the only repository out there. In fact, you'll see a different repository when we work with Singularity, because we use Docker with Singularity via the key.io repository. Okay, so let's have a look at so Docker, as well as being an online repository you can access through the Docker command. The Docker Hub actually has a website. It automatically has a repository website where you can see more information. So let's go. I'm going to follow this link here to hubdocker.com/_/Python to look at a typical Docker Hub software page. So here I am. I'm going to make it a little bit bigger. So this is the these are the official images for the Python, essentially for the Python programming language. Okay, provided by the Python developers for people to use, because Python's a tool that people often want to use. So I've got, it tells me you can get a free Docker ID. Well, that's just because I'm not logged in on the web. That's fine. And what it tells you here is what different versions of the image are available for you to pull and use. So there's various different ones. There's quite a lot of tags. So there's these tags with a bullseye or a slim and bullseye, and various, because there's a lot of versions of Python people want to use on a lot of systems. There's a lot of different versions of the image out there that are provided by the system. Then it tells you a bit more about what's provided by the image. So it says, what is Python? Well, most people know what Python is. It's a programming language that's commonly used. How to use this image. So there's some examples of how to use this image within a Dockerfile to build your own images, or how to use the image to run a single Python script. There's some example commands there, and what the different variants of the image are, whether the Slim, the Alpine, Windows Server, and those sort of things, and some information on licensing. Okay, so it gives you hopefully all the information you need to make use of that image. It tells you, it's even got a command you can copy and paste to try and it shows you how to get hold of the image, and then the examples of how to use it. And here are the different tags, and it even gives you a simple way to copy the command to Docker pull onto your system for the different versions. Okay, so all images on the Docker will have a page like this. Okay, some of them may have more information than others. This one had a lot of information because it's an official image that's provided by Python and is used by a lot of people. And so the way you pull them, you may have seen there for the web page I was looking at. You can pull, as well as just pulling Python, which will give you some sort of latest or default version. You can add a colon and the name of the tag from the page to pull a specific version. So say you wanted Python 3.8, you could do Python : 3.8, or if I wanted Python 3.6, I'd do Python : 3.6. The default tag, which is usually when you don't specify, is called latest usually. Okay, and when we looked at that image, so yeah, so the images we've used, if you've noticed, and the ones here, like Python, are ones that are maintained by the Docker team, are official images. but quite often you'll see images individual by individual owners or other organizations. Now, if they're not the same, if they're not provided by Docker, then you get an extra bit in the name of the image you want to pull, and that has the name of the owner of the image beforehand. So, for example, if we look at the Rocker page on Docker Hub, which is used for some of the R scripting. If you've ever come across the R statistical language, this one, oh, just a minute, yeah. This one, you can see that the names of the containers, instead of just verse or tidyverse, have the owner in front of them, which is Rocker, because they're provided by the Rocker organization rather than by Docker Hub directly. Okay, the technical name for the contents of a Docker page is a repository, and the tag indicates the specific version. So usually it's owner repository and then tag. Okay, so there's a question here: how would you download the Docker container image produced by the Rocker group that has a version of 3.6.1 of R and the tidyverse is installed? So we're not going to actually issue the pull command because it's very large, but essentially it would be Docker image pull, the owner, which is Rocker, the repository, which is tidyverse, or the container, or you can think of that as the container image name if you want, and then the tag, which is the version 3.6.1. There's lots of different container images on the Docker Hub, and that's where the real advantage is. One of the real strengths of containers, particularly Docker containers, is there's just a huge amount of work that's already been done for you. You know, quite often you don't need to create a new container image because the one you exists already there. Can you get the size before pulling it? I don't know the answer to that, Lucy. I'd have to check it out. I'll go look at a page in a minute. But what that does mean is, because anybody can upload a container image for people to download via Docker Hub, is that you do need to be a little bit careful about what you pull from the system and assess, you know, how safe it is to download that particular container. So, you know, there are some indicators that a container image on Docker Hub is consistently maintained, is functional and secure, and there are things like the container image is updated regularly. You can see a lot of activity there with people working to update the container images over time. The container image is associated with well-established company or community or other group that's well known. For example, we saw the Rocker ones there. Rocker is a well-known community for working with R. There's a Dockerfile or other listing of what's been installed into the container image, so you can see exactly what's going on there. And the container image page has documentation on how to use the container image. So people have taken the time to write down how you would use it and document those things. These are all things that show that people have taken care and that the container image is more trustworthy. Conversely, if you see a container image page that's never been updated, it's created by a random person you've never heard of, does not have a lot of metadata associated with, then you maybe want to think a bit harder before downloading such an image to your system and trying to use it. Okay, because there's less a guarantee that it's going to be safe, or that it's even going to behave as you expect it to behave and do the thing you expect it to do. You know, so even if such a container is secure, it's not reproducible probably, and it's not going to be a dependable way to run research computations, because it may just disappear at one time and maybe updated or changed without any warning or any confidence the same. What I would say is, you know, we're not going to do it right now, but you know, take time to browse around the Docker Hub and have a look at what's there. Particularly look for things that may be relevant to your research and get a feeling for. There you go. Thank you, Jeremy, for answering that question. So get a feeling for what's out there in your research area. And I think, you know, you'll get a pretty good sense pretty quickly of, you know, which ones are reasonable images to potentially use, and which ones are maybe not where you'd want to start, just by the amount of content on the Docker Hub pages about those images. So, you know, I think it's worth taking the time to have a look around Docker Hub and see what's available in the research area you're interested or you work in. So you can you know, if you find something that you're interested in, you want to explore using it, then once you've satisfied yourself that it's you know, that it's something reasonable for you to download, then you can just pull it and have a play around with it on your local system and see if it does what you want. As we'll see later on this afternoon when we talk about creating images a bit more, you could use these images that are on Dockerhub as a jumping off point to create your own images. So, you know, you can start from the Python, the official Python image, and say you need more packages, more Python packages that are installed in that image by default. You can then add them to yourselves and re-upload those things to Dockerhub, or just use them on your local system. We'll see how to do that later on. So, oops, that was me skipping backwards by accident. So the Dockerhub's got massive amounts of stuff. So, you know, don't feel you need to start from scratch when you're creating your own containers, because somebody's often done it for you, or has something very close to what you want, which you can just build on top of, with adding minimal stuff. But do satisfy yourself that the image you're going to use from the Dockerhub is stable, secure, useful, and trustworthy before you go ahead and use it. And we've outlined some of the key indicators there. You know, it's not hard and fast science, but I think as you browse around Dockerhub and get more experience with it, you'll quickly get an idea of what is a trustworthy container image and what isn't. Okay, so we're now going to move on to creating our own container images, because this is where the power comes from. It's great. Using existing container images can save you so much hassle on your day-to-day use of computing, and we'll hopefully see an example of that this afternoon. But you know, a lot of the power from using Docker and container images and Singularity and these things comes from the ability to create your own container images. So we're going to discuss what a Dockerfile is and how you create a recipe for creating a container image, show how that works, and then show how we can push that back up to the Dockerhub so other people can download and use it. Excuse me. So the reasons you might want to create your own Docker container image, things like you can't find a container image on the Dockerhub or on another repository which has all the tools you need and all the bits and pieces you need for your research. You want to have a container image to archive the specific software versions you ran for a project or a particular piece of data analysis, or those sort of things. So that's the sort of reproducibility argument. You know, you've got this thing for posterity that you say, this is what I did for this research paper or for my thesis, and you know, I've got it all captured and contained here. Or you want to share your workflow with somebody else and make sure that they get the same results and are using the same sorts of tools and those sort of things. And container images can make it really easy to share that without having to provide a long list of detailed instructions. We need to install this bit of software and then that bit of software, make sure that version's there, build the command in this way, add these options. You can build all of that into the container image before you share it with somebody. So we're not going to finish this before we break for lunch at 1/4 past, but we'll get started. Okay, so before creating our installation or our container image, we want to experiment with installing the software inside a container itself, a running container. So we're going to go back to our Alpine Linux container. I'm going to start up an interactive session in it. And then we're going to say, well, we want this Alpine Linux container, but we really want to use Python 3 in it. So let's start the container. First of all, this is a toy example. This isn't the way you'd approach, particularly with Python, because as we've just seen, there's official containers out there. But let's, for the sake of argument, we're just showing it that we have a container. We want to run the Python. We want to run some Python 3 script. But within the default Alpine container image that comes from Dockerhub, there is no installation of Python 3. In fact, there's probably no installation of Python at all. There's no Python 2 either. Okay, so what we want to do is create a container image based on the Alpine Linux one that is able to run our Python script. Now, remember, we're root inside the container. We're the super user, we're the administrative user. So we can install whatever we like there. You know, we've got complete power to do that. So we could use the Alpine Linux package manager command. So if you've ever used something like Ubuntu or something like this before, you've seen apt apt get install and those sorts of commands, or yum install for some other package managers. The one for Alpine is called apk, and we can use it to download and install Python from the Alpine Linux repositories. Okay, so let's try that. So this goes away to, you can see here, sorry, to the Alpine Linux repositories and looks for the various versions or the various bits and pieces we need to get Python 3 working, and installs them in our container. Okay, so now Python 3 is installed in the container, as simply as that. Because we're super user, we can do that. And once Python's installed, now we've installed Python, we can use the standard Python tools to add other things using pip, for example. And they work in exactly the way you'd expect them to work, as if you had root privileged super user access on the system you're running on. Remember, we're still in the container here. This isn't on my, I'm not overwriting the Python 3 installation that I've already got on my host system. I'm not overwriting the Cython installation I've already got on my host system. This is all happening within the container, so I am not affecting my host computer at all with these commands. Okay, so this is a safe, or do you think there's a sandbox environment where to try out these things and make sure that I've installed the right version of software. And there's an exercise here. Can you find the instructions for installing R on Alpine Linux, and do they work? Well, you won't be surprised to find that there's an apk command to add R. Okay. Now, the challenge is, of course, once we've exited out of our container, okay, our changes aren't saved. You know, I've got Python 3 on my host computer, but if I start up that container again, the Alpine container, exactly the same way, and then try to run Python 3 again, it's not there anymore, because when we stopped and exited out of our container, we've lost everything we've done. Okay, there are commands that can snapshot the current state of our container and save it into an image. But that's not really a very reproducible way to go about installing things and setting up container images. So, and we don't really cover it in this course. So instead, we're going to take the more sort of systematic and reproducible way, and we're going to take what we've learned from doing this interactive installation and use it to create a reproducible recipe for creating a container image in what's known as a Dockerfile. So I'm going to exit back out of this. Running container back to my host computer. So a Dockerfile is a plain text file with the keywords and commands that we use to create a new container image. So as part of the setup installation instructions for this course, it asked you to download this Docker intro zip file. Let me go back to the top level. I can show where that is. So in setup here, there was files to download, and it said download the docker intro.zip. So I'm going to get that link. I'll paste it in the chat in case people can't find it. That's the URL to that file. I don't have it here, so I'm just going to get it on my command line using wget. So I've downloaded the zip file, which has for this lesson using wget, and then I'm just going to unzip that to get the folder. Okay, I'm going to go back to my lesson, back to the episode we were working on, which is creating your own container images. Where were we? Okay. So now we can run this command wherever you put it. This assumes it's in the desktop. Mine isn't. But I'm going to go into Docker intro basic, and there's a Docker file in there. And if I cat the Docker file, as you remember, cat shows me the contents. It should show this. So this is a sort of a template Docker file where we've got to fill in the bits. Okay, and we'll break this down. So the first line, the from command, tells us which container image we're starting with, the base of the container image we're going to start from. Now, in our case, that's going to be the Alpine, the container we ran up here, which is going to be the Alpine container. Okay. Then we've got some sections which are called run, which are the install commands we used in the shell to install the tools we wanted in the container. Okay, so just as if we were typing the command line, we can substitute those commands in there, and when we build the image, it'll be repeated for us. And then finally, there's a CMD. This indicates what the default command we want the container based on this container image to run. So this is, remember before when we ran the hello world container image, it did something by default. This is where we specify what we want that to happen by default if somebody runs a container based on this container image. If somebody doesn't supply another command to run, okay. So we provide the command in what's called the exec form, and we'll see what that means in a minute. But essentially, it's in square brackets strings that represent the command we want to run. So anything that's separated by commas will be put together with spaces in the final container. So, for example, ls, comma, minus lf, comma, minus color, comma, slash etc would translate to command ls minus lf minus color slash etc. There is another way to do it, which is the shell form, which is more old-fashioned and is kept for legacy. You know, you can just put the actual command you want to run after the CMD definition in the Dockerfile. But we're going to stick to the exec form because it's more explicit and it allows more flexibility in container image. So what I'm going to, so we're almost at the end here. We've got 2 minutes to the end. So I'm going to stop right now. And then when we come back, the first thing we would do is have a go at this exercise and have a go at filling in a sample Docker file without looking at the solution to replicate the installation we did up here interactively. So we can create a container image based on the Alpine container image that contains Python 3 and Cython. Okay, so that's where we're going to start when we get back after lunch, is having a go at constructing that Docker file. Okay, so I'm going to stop there, and we're going to restart again at 2 o'clock UK time. So that gives you about an hour and 3/4 break to get some lunch and rest your brain, hopefully, and take a break away from online teaching, because I know it can be a bit draining. And we'll start again at 2 o'clock with that exercise. I'm going to hang around for a little while now, so if people have any questions before they go away to lunch, I'm happy to try and answer them. But please don't feel you have to stay and ask questions. If you want to just go away and get your break and come back at 2 o'clock, that's perfectly fine too. So if you're just going, I'll see you again at 2 o'clock and start again. If you stay, I'm happy to try and answer some questions. I'll speak to you. I'll stay around for a while to do that.
Yeah, likewise, just to add to what Andy said, I'm happy to stick around for another 15-20 minutes if people have any questions. So do feel free to stick around and ask questions, but equally feel free to head off and take a break, and see you at 2 o'clock.
Hey,
Yeah, come on.
and thank you for the good session earlier today.
That's fine. Thank you. I'm glad you enjoyed it.
Yeah, it was like I'm trying to get up to speed with it. So just a few things, and I just want to make sure that I understand it right. So so when we have an image is like an static thing. But once we instantiate it, or once it starts running, that is a container. Is my understanding correct?
Yeah, that's exactly it. So a container is an instance of an image that's running.
Okay. So so image is like it is sitting there, not consuming any resources, and once you start it, that becomes a container, and that starts to consume RAM and stuff. So in order to run a container, you need an image.
Yes, exactly. The only resource the image consumes is disk space when it's local, because it has to be stored locally before it's started. And so that's the pull that it's downloaded from the repository, wherever that is, be it Docker Hub, be it somewhere else. It's downloaded, stored locally on your system, and then that file, that data, is used to launch an actual running instance of the container. And then, as you say, it consumes CPU resource, RAM, and those sorts of things while it's running.
Perfect. Yeah, thanks. Thank you very much.
No problem.